Bismillahirrahmanirrahim. Alhamdulillah, this morning we can meet again by online, for numerical analysis class. And today we will continue on interpolation. But before we talk about interpolation, I think we haven't discussed about the midterm exam, have we?
Not yet, ma'am.
Okay, all right. So, yeah, we will look at on the midterm exam. Wait a moment. Yeah. Okay. So about the midterm exam, we have 3 questions. Yeah, in which we want to solve for A. We have the trajectory of a ball is defined by this coordinate. Yeah, and the trajectory can be modeled as this one. So this is the coordinate of y, in which this is a function of x and tangent of theta 0. Yeah, so we have the value here. So we have the initial velocity, in which this is 18 meters per second. And then we have the distance to the catcher with the 30. So this is the distance, 30 meter. And this is thrown with an initial velocity of 18 meters per second. And the ball leaves the thrower's hand at an elevation of 1.5 meter. Yeah, so y0, so the initial height is 1.5 meter. And then the catcher here receives it at 1 meter. Now the gravitational acceleration is known. And here the question is find the appropriate initial angle theta 0 in degree using bisection method with initial case theta here is already known. So we have the value of the limit already for the bracket. And we want to do the calculation with the approximate error up to 3%. Yeah. So that here when we want to solve this one, so that because this is a problem of finding the root, finding the value of theta 0, in which this will satisfy this equation. So that here we see that we have y is 1 meter, so that we can insert the value here is 1 meter. Yeah. And then we have the gravitational acceleration already. And we have the distance to the catcher, which is 30 meters. So we have this 30 meter. And we have v0, the initial velocity is 18 meters per second. And we have x squared here, which is 30 meter again. Yeah, 30. And y0 is known as 1.5 meter. So that with this, we know all of the variable except for theta 0. And the question is find the value of theta 0 in which this will satisfy this equation. So what we can do is that we rearrange the equation so that it becomes the problem of finding the roots of equations. So that means we have to make one side as 0 value. So that with this, we can move that to the right side so that we have 0 is equals to tangent theta 0 times x, minus g divided by 2 phi 0 squared cos sinus theta 0 x squared plus y0, and this is moved to the right hand side so that we have minus y. Yeah. So that we have minus y. So that with this, all of the variable is known. So that what we have here is now finding the value of theta. Yeah. So what we can do is that we can find the value. Yeah, we can insert the bracket. Yeah, so that we need to find the value. So say here we have yeah, we have the value for the left. Yeah, so say we have theta 0 for the left, the lower limit. Yeah, and for the upper limit. Yeah, so that we have 0 and 50. And then we have to check, yeah, whether the value of this one, so this becomes f theta 0. Yeah, so we have to find the value of f theta 0. Yeah, so that we have to find the value of f theta 0 at for u. Yeah, for u, for lower limit. Yeah, yeah, for the lower limit. And we can also find f theta 0 for the upper limit. And then we check for the value. It means that we need to insert the value of 0 and 50 here and see what is the value here. Yeah. So if it's positive and negative, or negative and positive, or the multiplication is negative, it means that there is a the root in between this limit. Yeah. So that what we need to do is next is finding the new value for the root. Yeah, so that we have to find theta 0 root, in which for bisection method, yeah, so it's very easy to find it. So that becomes theta 0 for the lower limit plus theta 0 for the upper limit divided by 2. So that once we have the value of here, we can calculate the new root, and then we calculate f theta 0 for the root and see whether this is positive or negative. Yeah. So for example, this is, I will see. Yeah, so that for the result here, we have, yeah, positive. Go back again to the slide. So that we have, yeah, so that we have the value here is that will be negative. Yeah, so this value will be negative. Yeah. And then we have the value here is positive. And this one, the value of the root here is negative. Yeah. So that will be 25 for this value. And then when we insert 25 here in the equation, so that we have negative. So it means if it's negative, so that this will substitute the position here. Yeah. So that we have to update the value of 25 here. Yeah, the value of 25 here, so that becomes here the left limit. Yeah, the lower limit. So that here will remain the same. So that this value here will replace this one, and this will be positive. And then the average will be 37.5 and so on. Yeah. So we do the calculation, and don't forget to calculate the error. So here we have to calculate the approximate error. Yeah. So that here to calculate the approximate error will be 37.5 minus 25 over 37.5. So if this is still greater than 3%, yeah, so it means that we need to repeat the calculation and so on. Yeah. Okay, so with this, to get below 3% based on my calculation, it will need 6 iteration. Yeah, 6 iteration, and the value will be, so theta 0 will be 30.468. Yeah, and this is in 6 iterations. Okay, and I think that most of you already get this correct. Yeah. Okay, and now we go on to, I will erase that. Yeah, so now we will continue to the second question, which is finding the root as well. Now we have different equation here. Now this is using the Newton-Raphson. Yeah, using the Newton-Raphson. So in the Newton-Raphson method, it means that we need to find the gradient. Yeah, so that means we need to find the gradient. So that the calculation of the new root, yeah. So the calculation of the new root will be xi minus, yeah, x, then the old value, f, yeah. So that will be, yeah. So that this will be the calculation for the new root. Yeah, the new root will be the old value minus x fxi I plus 1. Yeah, so that will be equal to that. So that it means that we need to find the gradient. Now, before that, we have to identify the function. So again, because this is a problem of finding the root, so we will see here that we have Q is the flow rate, S is the slope, H is the depth, P is the width, and N here is a constant value of the mending roughness. And we have the value for Q already. So this is a constant. We have S, we have P, yeah, and then we have N, which is 0.03. And then we want to solve for H. Yeah, so the unknown is H here. And we want to get the unknown which will solve this equation, which will satisfy these equations. So that here the initial value is provided H is equal to 1, and we want to iterate to approximate error below 1%. So the important thing is that to get the function here. Yeah. So how to get the function? So say we insert that in the equation. So I have Q, and then we have the square root of S. So here we have the square root of S. Yeah, for example, this is the value. And we have P. P is 10. So I will write it down. So that will be 10 times H to the power of 5 over 3. And then this is divided by N. So N value is 0.03. And then we have P value, the width is 10, plus 2H, close bracket, to the power of 2 over 3. Yeah. All right. So that with this, so we have to construct an equation, yeah, an equation in which this will be equals to 0. So that we can move that, we can rearrange the equation, we can bring that to the left-hand side. So for example, here we have 0.09, 10 plus 2h to the power of 2 over 3. And that will be equals to the square root of 0.0002, 10h to the power of 5 over 3. So this is the equations, yeah. So that here we can find this if we want to make that 0. Now to make it easier, we can power this equation, yeah. So the left and the right term here with 3, so that we have a simple, more simpler calculation, yeah. So that we have 10 plus 2h to the power of 2, and that will be equals to the square root of 0.0002 divided by 0.09, and this is power by 3. Then this is multiplied with 10h, yeah, to the power of 5. Yeah. So then we have this one, yeah, so that will be A to the power times h to the power of 5, and that one moves to the right hand side. Yeah, so this if we have a quadratic equation like this, so this will be 100 plus 40h plus 4h squared. So we move that to the right hand side, yeah, so that we have 0. That be equals to a, which is the constant here. So this is 10 to the power of 5. Yeah, a h to the power of 5. A is the constant, minus 4h squared, minus 40h, the minus 100. So this will be the equation. Yeah, so this will be fx. Yeah, so fx will be equal to 0. So this is fx. Yeah. So once we have fx is defined, so that we can find fx and x. So fx and x will be 5a h to the power of 4 minus 8h minus 40. Yeah. So this fx. So that if we have the initial value of 1, yeah, we can insert this and find fx and x and also fx. So we insert it there. And this is 1 minus fx over fx and x. Right? So that we have the new value for the root. New value for the root. And then we should check for the error as well. Okay. So based on my calculation, we have to get below 1%. Yeah. Now this is depends on how many significant digit that you use. Some may get the result of 3 iterations, and the other may have 4 iterations to reach an approximate error below 1%. So about 3 or 4 iterations depends on the numbers of significant digit. And the result will be H will be 0.8097 meter. So this is the result. Yeah. So this is for number 2. Okay. So is there any question for number 1 and number 2?
Not yet, ma'am.
Yeah, I think this is quite straightforward. Yeah, so you can, it's very simple. Yeah, so I will clear. Okay. So that now we will continue. We will continue on the third question, yeah, which is about a truss structure. So this is a very simple truss structure. Wait a moment, just move this. Yeah. Okay, so we will see here that we have a truss structure with an external force applied at the bottom here. And then we want to find the forces on the member of the truss and the reaction forces. So here we have free body diagram. At each node should be analyzed and calculated for the forces. So what we want to find is from F1 up to F3. So we have F1, F2, and F3, and then we have Rx1, Ry1, and Ry2. Yeah. So that here, then we want to calculate for P1. We have the right-hand side P1, P2 up to P6 based on the data here. Okay, so that we want to construct this one. So that we can see for the calculation for the truss. Yeah, so that yeah, so that we will have here. Okay, so I will open this one. I will share a new slide. Yeah, sorry, it's looked like a bit disconnected. Yeah, so that yeah, so we will see here that so this is the calculation. So you can see it already, yeah, in the screen. Okay. So this is the calculation for the free body diagram. So we have to make the calculation for each of the node. Yeah. So for the first node here, we want to get the value of Rx1 and Ry1 for also finding the component of F1 and F2. Yeah. So that if we have F1 here, so that we have F1 and the angle here is 45. Yeah. So here the angle is 45. So that we have here, sorry, this one, yeah, so this one is 45. So that one, this F1 here, we have two components. Yeah. We have, okay. Yeah, so we have here the component in horizontal component, yeah, the forces in horizontal component, so that we have Rx1 and also we have, so this should be Rx1, F1, yeah, cosinus. So where is that? It looks like it's been erased. Okay, so what we have here, we have Rx1 plus F1 sinus. So this is 45. So in horizontal, so that will be F1 cosinus 45. Yeah. Plus F2 cosinus 30. And in Y direction, we have Ry1 minus F1 sinus 45 minus F2 sinus 30. So that we do the same for A, B, and C. And then this is the result. Yeah. And this is the result. So that we have here, so that this should be 1 here. Yeah. Okay, so this is the matrix that we have. So it's not really clear perhaps. Yeah. So that yeah, I think there's a bit problem with my computer. Okay, so that yeah, so that here the most important thing is that yeah, you need to do Gaussian elimination, but the most important thing is that when you want to calculate this sort of problem, yeah, using any method. So here I will show you that we have the value of A here, which is obtained from the calculation, yeah, from the calculation from the node that we have. Now, the most important thing is that when we have this sort of matrix, is that we want to make it diagonally dominant, so that you must do pivoting and try to make the system to be easier to be solved by using by rearranging the equations so that you have diagonal dominant here. Yeah. So the element will be here. So that once you have the diagonal element here, all has a value of non-zero, and try to make this to be the largest value. And then you rearrange. And of course, the B value here will be changed. So for example, here, the last row here, which is 3 here, so that I move that to the second. And once we have this one, so that you can apply this, yeah, you can apply this to find the Gaussian elimination. So this is our, just do some checking with Excel so that we have the solution here as shown here. Okay, but the main thing is that if you do not rearrange this one, you might have problem. Yeah, sometimes you will end up with no solution if the diagonal element contains 0. And I noticed that that will be the problem. Yeah, some of you have the problem of difficulty of doing elimination because this is not in a diagonal dominant matrix. Yeah. Okay. So I think that will be the explanation for the assignment. Is there any question for the quiz for the term exam? Is there any question?
Excuse me.
Yes.
Is that the grade of our midterm exam sudah keluar?
Yeah. It's not yet. I'm trying to have the result by tomorrow or Friday morning. Yeah, hopefully. Yeah.
Okay, ma'am. And if one few of us has grade below the KKM, there is will be a remedial or something that we need to do.
Okay, so I'll check the result again later, and we will decide that after we have the marking finished. Yeah, so that I will let you know through the WhatsApp group. Yeah.
Okay, ma'am. Thank you very much, ma'am, for your information.
Yeah. All right. So is there any problem with this for the third question?
Excuse me, ma'am. If
Yes.
in the diagonal dominant, like in the pivoting diagonal dominant, is it okay if the pivot is still not diagonally dominant? Because in the slide in the Excel, in the pivot is minus 0.7, but in the right there is 1, so it's not diagonal, ma'am.
Yeah. So when we talk about pivot element, we are looking for the largest magnitude. So it doesn't matter whether it's negative or positive. Yeah. But we're finding for the largest value. And what about this value with we have 0.7 and then this is 1? What we do is pivoting in row direction. Yeah, it means that we pivot the row but not in column. Yeah, because as we have discussed before, yeah, if we do total pivoting, yeah, it means that we do pivoting in row and also column. The column here will make the order of the unknown here also changing. But if we only do pivoting, partial pivoting, it means that we only change the order of the row. So that means the unknown here, the factor of the unknown here remains the same. Yeah, so that when we do pivoting, we just look for the value in the same column. Yeah, in row in the same column, but we're finding for the largest value in the row. Yeah, in the column. So which row will be the largest? So that we want to choose that as a diagonal element. Yeah. So this is crucial, yeah. So getting this matrix structure like this one, this is very crucial, yeah. So because if for example you have this sort of matrix as well, sometimes you will have problem using any method, yeah. So not only Gaussian elimination, but if you do iteration as well, yeah, sometimes it will be taking very long to converge as well, yeah. Okay. So, yeah.
Sorry, ma'am. But I mean that if I search in the internet, ma'am,
Yes.
diagonally dominant is if the kayak I'm sorry in Indonesia, ma'am.
Yeah.
Kalau misalnya 0, diagonal utamanya itu kalau harus lebih besar daripada jumlah di samping-sampingnya, ma'am. Misalnya 0,07 ini harus lebih besar daripada misal nanti di C ada nilai 2, D1 berarti minus 0,7 ini harus lebih besar dari 2 tambah 1 gitu. Yang diagonal dominan.
Oke. Ya, itu ada kasus khusus ya. Jadi so there's what you are talking is correct, but this is that kind of problem usually arise from a special case which is derived from the partial differential equation. Yeah, so when we have when we apply partial differential equations later, you will learn. Yeah, we will get into that as well. You will learn that the diagonal element will be the largest value because this will be the addition of all of the element on the other column. Yeah, so that is a spatial problem which arises from the partial differential equation. Yeah, but in general, when we don't talk about that, so this matrix can have any element. Yeah, so it's not necessary that the diagonal will be the largest. Yeah, so that is for the general case, but for PDE, yeah, in special case in PDE, that is correct. Yeah, so usually, yeah, the largest value will be the diagonal, and that will be the summation, yeah, for all of the element on the other column. Yeah, but that is a special case in PDE, and this is not a requirement. Yeah, when we do pivoting. Yeah, so this, the one that you ask, yeah, is naturally derived from the PDE. So naturally derived like that. Yes, jadi hasil dari diskritisasi PDE nanti secara otomatis akan memberikan hasil seperti itu, bahwa akan diagonal dominant. Ya. But in this case, we are not talking about PDE. So this is another case for the truss, and it can arrive in any form. Yeah. So the matrix can be in any form, and when we have this this kind of matrix, yeah, so that this is not necessarily to be one. Yeah, not necessarily to be the addition to the summation for all of the element aside. Yeah. Okay. But yeah, it's not always like this one. Yeah, you can choose other, but this structure, I think, is the most optimum. Yeah. For example, we have 1 and -1 here, so you can switch that row. But the problem is that later we will have 0 for the diagonal element for the first column. Yeah. So that we want to get the optimum structure, so that it will more or less have a maximum value in the diagonal. So for example, we see at the second column here, yeah. When we see at the second column here, we see that 0.5 here might not be the maximum value, yeah. So we have 0.866, yeah, here. So this is this is larger. These value are larger than 0.5. But here, when we want to make the matrix as diagonal dominant, so that we have to also consider the other rows. Yeah. Okay, so I think that will be the discussion, yeah, for question number 3.
Thank you, ma'am.
Yeah. Okay. Now, before we continue, so that here, I just want to make you know that I have a problem here, that there is a blackout here at the moment, and unfortunately my computer is only have about 1 hour left, or maybe less. Yeah, so we will try to catch up with that. Yeah. So that yeah, I will continue to the material now, yeah, which is about interpolation. Yeah, so now we will jump on the next part, yeah, which is about interpolation. And I think you have learned of this before. Yeah, you have learned about interpolation before. So the simplest example of interpolation is in thermodynamics, in which we have the table, yeah, the thermodynamics table, and then we want to find a properties, for example, at a certain pressure, yeah, or at a certain temperature. And sometimes the value that we want to find is not exactly available in the table. So what we want to do is what we can do to get the value is to do interpolation between the value that we have. Yeah. So what is actually interpolation? So this is an estimation of intermediate value between precise data points. So it means that we have data points, and we need to find the intermediate values. Now, the simplest one that we use in thermodynamics is a linear line. Yeah. So that, for example, here we have, say, the temperature, and we want to find, say, the enthalpy, yeah, for example. So that here, say we have one point here and we have another point. So the simplest one is just connect that 2 points with a linear line. And then, for example, we want to find it here. So this is the one that we want to find the interpolated value at a certain temperature, for example. So this we can use it by finding the value from the linear line. But now what we want to learn here is that we can extend to higher order scheme. Yeah. So that if we look at the polynomial interpolation, so in general, it will have the form of fx. So the function that we use to interpolate the value here will be equals to a0 plus a1x plus a2 x squared plus and so on up to a n xn. So this will be the nth order polynomial. So if we use only two terms here, it means that we have first order or linear line to approximate the function between these 2 points. If we take three terms here, so that it means that we have quadratic equations to approximate the value. So that when we want to find the quadratic equations, it means that we need more information. If we want to have the quadratic approach, it means that we need at least 3 points. Yeah, when we want to get a curve, a quadratic equation, so that means we need to have 3 points. So that we see here that if we have n plus 1 points, yeah. So for example, if we have n plus 1 points, so that the highest order will be the nth order. On the other hand, if you say that we have 3 points, so the highest order of accuracy that we can get is second order. If we have 5 points of data, it means that the highest order that we can use to approximate the data is fourth order equations. Yeah. Okay. So we see here that first order linear line, we need 2 points. For second order or quadratic, it means that we need 3 points. And third order, we need 4 points here. Yeah. Okay. So that now we will see on the explanation here. Yeah. So we look at here, we have the Newton polynomial and the Lagrange polynomial. Yeah. So we will look at the first method, which is the Newton polynomial or the Newton's divided difference interpolating polynomial. So we see here that when we have the linear line, so it's very easy to get that when we want to approximate a value in which this is the approximated value or interpolated value of a point of x here. So that because we approximate with the first order, so we give a subscript here as 1. So f1x, yeah, minus fx0 over x minus x0, that will be equals to the slope, yeah, in between the point of 1 and x0. So we will look at the illustration here. So say if we have 2 points, yeah, x0 and x1, and we have the value of fx0 and f1, so that we can connect that with the linear line, yeah. So that now we have the slope of the line. So that if we look at here, we have delta y1 over delta x1, the tangent of the slope, that will be equals to delta y2 over delta x2. Yeah, or we can say that delta y1 over delta x1, that will be equals to delta y2 over delta x2 because the slope is the same. Or that we can say that delta y1 is f1x, the interpolated value, minus fx0 over delta x, it's x, the value that we want to find, minus x0, and that will be equals to fx1 minus fx0 over x1 minus x0. So that when we want to find here the value, so we simply move that to the right-hand side. Yeah, so that what we have here, so that we move that to the right-hand side so that we have this form of equations. So that we have fx0 plus this one is the slope. Yeah, the slope times x minus x0. Yeah, so if we see here, so this is the slope, yeah, of the 2 points that we have, the 2 data points that we have. So f1x, the interpolated value will be fx0 plus the slope, which is 1, yeah, times x minus x0. Okay. So this is the typical interpolation that we use. And even in thermodynamics, we have used this before. So this is not a new thing. Now we want to extend further. If we want to have a higher order interpolation, so that now, say we want to use quadratic interpolation, so that now we use 3 data points, a minimum of 3 data points, so that now we can find the second order equations to approximate the 3 data points here. So that how it looks like, so f2x will be written as p0 plus p1 times x minus x0 plus p2 times x minus x0 times x minus x1. So if we look at here, so this is x and x by x, so that will be x squared. So this is in general a second order or quadratic equation. And we have this value. So what is x here? So x here will be the unknown value, yeah, the value that we want to find at a certain x. And this will be the interpolated value. So how to find the coefficient here of P0, P1, and P2? So how to calculate that? So that we have here, we have 3 boundary conditions, yeah, in which at x0, yeah, which is the data point, the first data point where we have x0, so that we have the value of the function, which is fx0. So that if we insert x0, so that we have the value will be fx0. So that will be b0 plus b1 times x0 minus x0. So that will be 0 plus p2 times x0 minus x0 times x0 minus x1. So these terms will be 0. This one will be 0. So of course we got p0 will be equals to fx0. Now, if we use the same one here, now we use the second data points here, we insert it into the equation so that now we have the value, which is fx1, that will be equals to b0, and b0 is already known, which is fx0, plus p1 times x1 minus x0 plus p2 times x1 minus x0 times x1 minus x1. So this will be 0. So we cross that out. So that here we got p1 value will be equals to fx1 minus fx0 over x1 minus x0. Yeah. Okay. And then what about p2? Again, we insert that x2 value here. Yeah. So when we have x2 value, so that now we can find for p2 by substituting the value of p1 and p0 here. So this is the result for p. So if we look at here, yeah, so we have here that this is the slope. Yeah, if you look, this is slope between x1 and x0. And this one is also slope between x2 and x1. So that p2 will be calculated by the slope at 2 minus the slope at 1 over x2 minus x0. So this is the representation or the illustration. Yeah. So if we have, for example, 3 data points, if we want to approximate a value here at x equals to 2, for example, so that here we can use only 2 points, that will be fine. Yeah. So that if we use 2 points here, we have a linear line, which is shown by the dashed line here. So the result will be here. So this is the interpolated value, which is f1x. If we use quadratic estimation here, so that we use 3 points here, we need a minimum of 3 points so that we connect that with a quadratic curve. So then if we want to find x2, so we insert into the equation. So this is the value that we have. Yeah, so this is the value of f2x, while the true value is here. So that if we have more points, for example, so this is the actual, the true solution will be, the true function will be ln x. So say we have 4 points, 5 points, and so on, so that we can add, we can use higher order function to approximate the interpolated value so that it will become closer to the true solution. Yeah. Okay. So this is how we solve for quadratic interpolation. Yeah. So that again, this is the same, similar to before. Now that to make it easier, we can write it down as this one. So when we have P1, which is the slope between 1 and 2, so that we write it down as F square bracket x0 and x1. So this means that this is the slope, the first divided difference between point x0 and x1, or the slope between x0 and x1. And P2 here is the second divided difference between 3 points, which is x0, x1, and x2. And how to calculate that? That will be, if you look at here, that will be F, yeah, the first divided difference between x1 and x2 minus this is the first divided difference between x0 and x1. And that is divided by x2 minus x0. So that, again, if we want to increase it to nth order interpolation, so what we have here is that we have f and x, so that will be equals to up to pn times x minus x0 up to x minus xn minus 1. So that, again, to find p0, p1 the same, but how to extend to pn so that we find the nth order divided difference. Yeah. And how to solve this? So this will be easier when we have this structure. So we see here that for P0, yeah, again here for P0, which is the zeros or the divided difference, so that will be equals to Fx0. Fx0 x1, so that will be Fx1 minus Fx0 over x1 minus x0. And then the second order divided difference here, that will be Fx1, x2, which is the first order divided difference between 1 and 2, x1 and x2, minus the first order divided difference between point x0 and x1. And this is divided by x2 minus x0. And then we can find for the third order, fourth order, and so on. So it's always using the value before, yeah, using the value before, but for different points that we have. So that looking at these steps, yeah, so that it's easier to solve it in the form of table. So that you can imagine this, for example, we have an array in the computer, yeah, in the memory of the computer. So we can arrange that as an array, and then we can do the calculation by finding the value in the arrays. Okay, so this is how it goes. So that, for example, we have 4 points. Yeah, we have x0, x1, and x2, and x3. So this is 4 points. So that it means that we can get the maximum of third order equations, yeah, for the interpolation. So what we can do is that we put that value of fx here on the right side. So this is from the data that we have. And then next, the third column is to find the first divided difference. So that by using this value will be calculated by, so if we have fx0, x1, so that will be equals to the calculation of, again, we look at here, so that will be fx1 minus fx0 over x1 minus x0. So that will be fx1 minus fx0 divided by, so this is 0, x1 minus x0. So that when we calculate this one, so we subtract fx1 minus fx0 divided by x1 minus x0. When we want to calculate fx1, x2, so that will be equals to fx2 minus fx1. So the slope between x1 and x2 divided by x2 minus x1. So to calculate this one, that will be fx2 minus fx1 divided by x2 minus x1. Again here, that will be fx3 minus fx2 over x3 minus x2. So that we get the second divided difference. Yeah. Sorry, the first. So this is zeroth order. Zeroth, the first, and this is the second divided difference. So how to find the second divided difference? So that now we have fx0, x1, and x2. So that will be calculated by, write it here, fx0, x1, x2. So that will be equals to fx1, x2 minus fx0, x1 divided by x2 minus x0. So that how to calculate this one, this will be equals to fx1 comma x2 minus fx0 comma x1 divided by the last point, which is x2 minus x0. Again, for this one, this will be calculated by fx2 x3 minus fx1 x2 divided by the largest x3 minus x1. So we got the second divided difference. Now we want to find the third divided difference, the fourth column. So that now how to calculate this one? So that will be equals to fx1 x2 x3 minus fx0 x1 x2 divided by the largest, which is x3 minus x0. Okay, can you follow this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so if you pay attention, so this will be very easy. Yeah. Okay, so once we have that, the value there, so then we can get the calculation. Yeah, so that we can get the value. Yeah, so that the top row here, yeah, looking at the top row, so this will be the value of P0, this will be the value of P1, and that will be the value of P2 and P3. Okay. Yeah, apologize, I'm a little bit fast because I really run out of battery here. Yeah, so if this close, yeah, the class is closed, so then we will continue next week. Yeah, because I just got an information that this will be last up the afternoon today. Yeah, unfortunately, sorry for that. Yeah, okay, so that we will continue here the example. So say we have 3 points here, so only getting the second order equations. Yeah, and we have the data here. So this is the data that we have. Yeah, we put it here, and then now we want to find f, the first divided difference and the second divided difference. How to calculate this one? So 2 is obtained from minus 3 minus 5, so that will be minus 3 plus 5, that will be 2, divided by 1 minus 0, so 1, so that will be equals to 2. 6 is obtained from minus 15 minus 3, so that will be 12. Yeah, minus 15 plus 3, so that will be minus 12, divided by minus 1 minus 1, so that will be minus 2. So the result will be 6. And this one we have 6 minus 2, that will be 4, divided by, so this will be the last, that will be x0, x1, and x2, so that the last will be minus 1 minus 0, so that will be divided by minus 1, so that will be minus 4. So we take this one, so this will be B0, B1, and P2. Yeah, so this is the calculation. Okay, how to get 2 is minus 3 minus 5 divided by 1 minus 0, so that will be 2. Yeah, again, the second row, minus 15 minus 3 divided by minus 1 minus 1, so that will be 6. And the last row, the last column, here we have 6 minus 2 divided by minus 1 minus 0, so that will be minus 4. Yeah, so that with this we have P0, so F2x will be equals to P0 plus P1 x minus x0 plus P2 x minus x0 x minus, write it down here, x minus x1. So that we have P0 is minus 5 plus P1 is 2 times x minus x0, so that will be 1, x minus 0. Yeah, x is the interpolated value that we want to find, minus 4. Yeah, P2 is minus 4 times x minus x0, 0, times x minus x1 is 1. So this is the result. So this is the equation. So say if we want to find at, say, half, 0.5, so that we can insert 0.5 here, and then we got the interpolated value. Yeah, we have f2x. Okay. Okay. So I hope this is clear. Yeah. Okay. Any question?
Not yet, ma'am, for me.
Okay.
Maybe not that one.
Right. Okay, I hope this is clear, yeah? So that we see, say, now we want to compare between these two data, which is actually the same, yeah? If we look at here, we have exactly the same data, but the order is different. So what about this one? So if we have this sort of problem, so that will be the same, yeah? So that will be the same. So the result here, so say we have different order, we will have the value of divided difference here, the value of B0, B1, and B1 here will be different. Yeah, will be different. But when we insert the value, because that will be x minus x0, x minus x1, so that when we insert the value later, when we do the calculation, it will be exactly the same. So when we use different order of data, that will be fine. Yeah. So the step will be different. Yeah. The coefficient here will be different, but later when you do the calculation, the final result should be the same. Yeah. So don't be confused of how to order the data. Yeah. It will be just fine. Yeah. So there will be no effect of ordering the data. Yeah, so ordering the points should not affect the interpolating polynomial. So the result will be exactly the same. Okay, so that here we have an example of, say we have 5 points, 1, 2, 3, 4, 5 points, and we have the corresponding value for the data. And we can calculate up to, because we have 5 points, it means that the highest will be 4th order. Yeah. So later we will construct this one, and we have x to the power of 4 as the highest order for the approximation, for the interpolated value. Yeah. Now this will be the task for you to read. Yeah. So I will just skip. So later you can read on by yourself. Yeah. So that when we talk about the error of this interpolating polynomial, so this is again because this is dealing with the order of the equation. So it means that the error will be the truncated terms that we don't include. Yeah, that we don't include in the calculation. So the rest of the term that is truncated, that will be the error. Yeah, or the residual. Okay, so that, yeah, I think you can read on that later. Yeah. Now we go on to the second, yeah, go on to the second method, which is the Lagrange polynomial. Yeah, Lagrange interpolating polynomial. So what? How to get the interpolated value? So that again, we can use many different order of n, yeah, nth order equation to approximate to interpolate the value. Now we have slightly different structure for the equation here, in which fnx will be sigma lix times fxi. So for example, we want to have first order, yeah. So then we have n is equals to 1. So f1x, yeah, first order. So that will be equals to L0 of x times fx0 plus Li of x times fxi. Yeah, so this is for the first order. If we want to increase to third and fourth, so that we can add more terms. Yeah, for example, we have second order, so that will be L2. Yeah, so this L1 is this L2 x times, so this should be 1, yeah, fx2. And if we want to increase to third order and so on, so just add again, yeah, and so on. Now the question is how to get the value of L0, L1, L2, and L3. Yeah, well, this one is the function, the data, the value of the data that we have. Now the question is how to get L0. So L0 here is defined by capital pi, yeah, in which this capital pi here, yeah, in which this capital pi here is actually means that this is the product of the terms here. So what is the meaning of the product? It means that this is the multiplication. If we have sigma sign, so that means we have to add plus, yeah, plus sign. But if we have product, capital pi signs means that we multiply. So say, for example, here, so then for the first term, for example, that will be x minus x0 over xi, x1 minus x0, and then we multiply with the rest, yeah, x minus x. So that will be multiplication. So that product, multiplication. So for example, like this one. Okay, so that's how to interpret this one. So that if we want to find Li, for example, we want L0. So there is a start here from j equals to 0 in which j should not equals to I up to n, the number of the order of the equations that we want to find of x minus xj over xi minus xj. Yeah, so that here for the linear version, so that will be L0, yeah, L0 x times fx0, in which L0 x will be x minus x1 over x0 minus x1. So we see here that this will start with a value which is not equals to 0. So x minus x1, yeah, it's not equals to 0, but here it is divided with the value of x0 minus x1. So you see here that 0 here comes first, minus the other value except x0. And if we look at here, we have L1. So that will be x minus the other value aside from 1. So that will be x0 over x1, the value of here, minus the other value, the same at the top, which is x0. This is times fx1. So you see here when we have fx0, so that x0 appears here, and this is the interpolated value that we want to find. Okay. Yeah. Again, for this one, we have fx1. So x1 here appear in the front, and that will be minus to the other value except x0, except x1. Yeah. So here when we have 2 points of data, when we have 3 points of data here, now this one is L0, and this one is L1, and this one is L2. And you can see the pattern here. F2x, so that means you have 3 points, which is x0, x1, and x2. And how to find the value of L0? So that will be x minus x1. Yeah. So you see here that here will be used as the division at the bottom. Yeah, so that appear at the division. And on the top, we have x, the interpolated value, minus all of the value except for x0. So that we have x minus x1 over x0 minus x1 times dot product x minus x2 over x0 minus x2. Yeah. For L1 here, this is L1. So we see here that we use x1 in the front, yeah, in the division, so that we have x minus x0, all of the value except x1 over x1 minus x0 times x minus x2 over x1 minus x2. And for L2 here, we have x minus x0 times x2, so it is appear at the bottom, minus x0 multiplied by x minus x1 over x2 minus x1. Yeah. So that we see here that you can have the pattern here. So say I want to have the third order version. Yeah, third order version. So that means we have an additional here, which is multiplied by fx3, additional term. Now, what about the value of L0, L1, and L2? And L3, of course, it will be different. So that with third order, it means that we have to multiply again. Yeah, we multiply again with x minus x3 because we have 4 points. Yeah, we have 4 points divided by x0 minus x3. So this is the addition to this one. So we have to add one term in the multiplication for L0. And then again here we have this multiplied by x minus x3 over x1 minus x3. And again this one This is multiplied again, additional term with x minus x3 over x2 minus x3. What about this one, L3 value? So L3 value will be x minus x0, x3 minus x0 multiplied by x minus x1 over x3 minus x1 times x minus x2 over x3 minus x2. Okay, so it's easy as that. So this will be L3. Okay, so you see the pattern, yeah? And you can read on the example here. Now, this is very critical, yeah? My battery is already critical, so it's only about few minutes, yeah? So that, yeah. So that for the rest, yeah, the class will be very short. For the rest of the time here, so you can read on this, and I think I have uploaded this in classroom, yes. So you can read by yourself the example. Okay, so we have the first order, second order example there, yeah. So then you can compare the result. Yeah, yeah. Can you hear me?
Yes, ma'am.
Yeah. Unfortunately, it really runs off battery. Yeah. So that, yeah, I'm using my mobile phone at the moment, but it will be very inconvenient. Yeah. So that I think that will be for today. Is there any question about the last, which is about the Lagrange interpolation?
Not ma'am.
Not yet, ma'am.
Yeah, so perhaps this is very short, yeah, and you might bit unclear at the moment about the Lagrange polynomial, Lagrange interpolation. So that I want you to, the task for today is to read on the slide. Can you open the slide already? The lecture notes on the classroom. Have you checked it?
Yes, ma'am.
It's available, yeah. It's available there. So that, yeah. You can read on that. Yeah, you can read on that and try to do the question that we have. Wait, the question. Yes, in which problem is that? In the book? Can you hear my voice?
Yes, ma'am.
Yes,
There is
ma'am.
not
Okay.
mentioned.
Yeah, I think there is one problem in this lecture note in which we have seen before, which is one question which is taken from the book, if I'm not mistaken. Yeah.
Is it with the logarithmic naturals, ma'am?
Yeah. Is it? Can you share the screen,
Yes, ma'am.
Joseph? Who's it? Abi? Yeah.
Yes, ma'am.
Wait, wait. Yeah. Can you share the screen of that, of the slide?
It is, ma'am.
No, not that one. We have can you before that? yeah, at the end of Newton's divided difference. At the end of Newton's divided. So before that, yeah. Again. Again at the bottom, we don't have that.
The two example, ma'am, or this one?
Not after this one. Is there any?
Oh, no, ma'am.
Oh,
There's
directly. Oh, okay. All right.
only this one.
Okay. Or can you help opening the book? Do you have the book? Yeah. Can you open it? So yeah, I will give you an assignment. So that will be an addition as well for yeah, in order to increase your mark, yeah, regarding the midterm exam as well, yeah, so that you can use the rest of the time to work on that.
Is it chapter 18, ma'am?
Yeah, about the Lagrange, can you share the screen of the book?
This is the Lagrange interpolation, ma'am.
Okay, so this is the Lagrange interpolation. So chapter 18. Okay, can you go to the bottom of that? We have problems at the bottom of chapter 18. Okay, yeah, thank you. So we can choose one example here, one problem. Okay, so yeah, we can choose, for example, here. Can you go to the bottom again? Next page, yeah. Okay. Okay, so I think we can work on example 18.28, yeah, 18.28, yeah, in which we have we want to find the sea level concentration of dissolved oxygen. So we want to find the concentration, yeah, of dissolved oxygen in the water, in which that will be a function of temperature, yeah. Now estimate the value at 27. So we want to estimate the value at 27 using linear interpolation, and P is Newton interpolation. Okay. We change the question, yeah. So the first one is using Newton interpolation, and the second is using Lagrange, yeah, Lagrange interpolation. Yeah. Okay. So A is finding using Newton's divided difference, and the second is using Lagrange. Yeah, so the problem that you use is 18.28. You want to approximate at temperature. Yeah? You want to estimate the oxygen concentration in temperature of 27. So it's between 24 and 32. And then we have 1, 2, 3, 4, 5, 6. Yeah. So we have 6 data. We have 6 data. And I want you to, I think, fourth order will be fine. Yeah. Using fourth order divided difference. Okay. So using finding the interpolated value using fourth order function. So when we use the Newton interpolating polynomials, means that fourth order, and also for the Lagrange is also fourth order. Okay. And then you can compare that with the exact result. So there is an exact result there in which the value is 7.986. So you can compare your result between the Newton divided difference and the Lagrange interpolation. Yeah, which one is closer to the value of that? Yeah, with the same order of accuracy. Yeah. Okay, so that will be the task for you. Yeah, for the rest of the class. And we haven't do the presentation, so I will call your name. Yeah. Or who is not attending? I think how many people here now? 38. So is Yasir here? Yasir not coming? Okay, so Yasir is not coming. Who else here? Can anyone tell Yasir to drop the class? Yeah. Sultan, can you help? Yeah.
Okay, ma'am.
Yeah, because he has not contacted me yet since last week. Yeah, about the midterm exam. So I think that will be final decision that he cannot follow the midterm exam. Yeah, so that I please tell him that he has to drop the class. Yeah. Okay, so who is not attending? Finding one person. Okay, so to make it easy, I'll just take a screenshot of this.